Hello, CS students. Today I'm going to introduce a problem-solving technique called recursion function to you. In these videos, we are going to learn the definition and implementation of recursion function. I will also walk through one of an application with you through the example of factorial calculation. According to the definition from upgrad.com, recursion is a process that function repeats to call itself either directly or indirectly for the problem solving. It is super useful to break the problem into subproblems through the sequential function calls. So let's talk about the recursion function structure. Recursion function structure has two cases, the base case and the recursive case. The base case of recursion function is a condition that stops the recursion function to call itself, which it helps to return the stack by stack. The recursive case is a condition makes the recursion to call itself over and over again until it reaches to the base case. Let us walk through the example with factorial number. We know that factorial number is a product of a positive integer and of the integer below it. For example, if we have 4 factorial, the evaluation of its product is 4 times 3 times 2 times 1. 1 is the least integer of this expression, and the product expression therefore should stop at 1. There is a special case with a factorial, which is factorial 0. The result is 1. Now you have seen the expression, but how can we achieve it through the recursion function? First, let us define the base case of factorial number product. The factorial number should either be positive integers or zeros according to the definition. Therefore, negative number of factorial number should always end with an undefined result. This is our first base case. Our function will stop if it has took a negative number for the calculation. The second base case is the factorial number is when the factorial number is 0. We know that 0 factorial is 1, so it should directly give us the result 1 if the function took a 0. The final base case is 1. We know that 1 is the least positive integers and its factorial product is 1. Every positive number factorial product will stop at 1. After we have learned the base case of factorial number, we know when the function should stop call itself. But when is the case that we want function to keep calling itself? Because the factorial number is a product of positive integers and of the integer below it, we want it to continue calling itself when the integer number is greater than 1. It should stop calling itself when the number reaches to the 1. Let us walk through the example for factorial with real coding. This coding is done by Python. We can also achieve the same result from different coding languages. First, we have defined a function called factorial, which we will use as our recursive function to calculate the factorial result. It has a parameter called input number, which it takes the factorial number that we want to evaluate. Previously, we have learned our base cases. Here, we have converted into the real coding. Our first base case is a negative number. We know that factorial result of negative number is undefined. Therefore, we can return directly with the error messages. In this example, with the error messages is error, the negative number factorial is undefined. The second base case is a special case 0. We know 0 factorial is 1, so we can return 1 straightforward. There is no more step need to take. The final base case is 1, which is the least positive integer with no more factorial product. 1's factorial result is 1, so we return 1 here directly. We also know that every factorial expression will have 1 as its last product step. After the base case, we are entering into our recursive calls. it will return the input number times the factorial function with the input number -1 each time. In our case with 4, we check 4 is not any of the base case, so it will enter into the recursive call with return 4 times factorial function with parameter 4 minus 1, which is 3. We keep the same process with 3. 3 is not any of the base case. It therefore will return 3 times factorial 2. We continue the process until the input number is 1, which it will return 1 directly. We will walk through the return process later, but let us verify the result for this coding. 4 factorial is 24, and our recursive function gives us 24. Our function is correct. This is our calling process from our coding in picture. If the number is not within the base case, it will continue calling the number times the factorial function call with the parameter that number -1. Because the valid factorial number is positive, it will eventually hit the base case 1 and it gets -1 each time after each call. So our function will not call itself infinitely. Let us visit the returning process to verify how can we achieve 24 as the factorial product. Once the function reaches to base 1, it will return 1. This calling frame is finished and the result will go up to its previous calling frame, which is factorial function with parameter 2. We know that result of factorial function 1 is 1, so we substitute the call with 1 in factorial function 2. 2 times 1 is 2, so the calling function of factorial 2 is finished and will return the result 2 is going up to factorial function with parameter 3. We continue the process and finally we can have reached to the result 24.